Hello everyone. In this video we will going to solve few questions on Gauss test. Now first let's see the statement of Gauss test. Here un upon un plus 1 can be expressed as this alpha plus beta by n plus rn by n to the power lambda. Now, if you guys haven't watched the video of Gauss test proof that I have explained it beautifully, kindly watch it once and then come. I will put that link in the description box because that proof is important and it has been asked in many years of universities exams. So now how will it be determined that the convergency and divergency of this Gauss test? First, we will look to alpha. If this alpha is greater than 1, then the series is convergent, but if it is less than 1, the series is divergent. But if alpha is equal to 1, then we will going to see beta. Okay, we have two constant terms over here. We will see beta then. Okay, now beta, if beta is greater than 1, then it is convergent, and beta is less than 1, then this is divergent. But if it is there is no failure of Gauss test. I think there is a failure, but I have solved many problems on Gauss test by none of the questions fail. So I can say that if beta is equal to 1 also, so there is a divergence in that case. All right, so let's look few questions. Okay, let's solve few questions. This is my first question, and you will very interestingly to find that this question is not new for you guys, as we have solved this kind of question in D'Alembert's ratio test. Okay, so so you can say that this can be an alternate to the Rabi's test, I will say, because when D'Alembert's ratio test fails, we use Rabi's test, right? And we required un by un plus 1 for this Gauss test, means we will start with the ratio test first and then we will move to Gauss test. I have taken this example. Okay, so what do we say? That this is a alternate to Rabi's test as well as the ratio test. Okay, you can say. Now first we will determine the un term. So un term is, I can clearly see here that the un term is sum of the even powers and the odd powers. Yeah, so this is 1. I have excluded the 1, right? So that 1 has nothing to do with the convergency and divergency of the whole series. That can be excluded, right? So now the next term is going to be this, right? Now we require un plus 1 term. In this case we're gonna have 2n square and one term extra of 2n square, so it's 2n plus 2 square. Okay, you put n plus 1 in place of that, you will get the same thing. All right, yeah. Now we require the ratio, so divide this and this. We can see that this term will get cancelled and I will be left with 2n plus 3 upon 2n plus 2 whole to the power 2. All right, now we will going to take common 2n. Okay, so we will take 2n common, so 2n, so 1 plus 3 upon 2n, 1 plus 2 upon 2n. Now this is actually 2n square, this because it has the whole power square, so this will get cancelled and I am left with 3 by 2n upon 1 plus 1 by n, because 2 will get cancelled, right? Now whole power 2. All right, now if you put here, we can see that if you put limit n tends to infinity, I can see that this will goes to 0, this will goes to 0, and I am having 1. And according to D'Alembert's ratio test, if the ratio of un upon un plus 1 is 1, then I can say that this test fails and we have to apply the further test. Okay, so here we will going to apply the Gauss test, and we require this ratio as it is. We will not going to put the limit of n as infinity, all right, because we are doing Gauss test and this is the turning point here. अगर आप ये चीज़ सीख रहे हो then you will going to master कि आपको यहाँ का जो टर्म जो रेशियो उसको बचा के रखना है. Okay, this can be written as 1 plus 3 upon 2n का power square, and ये इसमें भी square है. You have to take it like this. In each and every question you have to solve like this. You will convert the ratio in the product form. Alright, we will take another question. In that question also I will be doing the same technique. You will see. Okay, now here I have converted in this product form, and now by binomially. Now binomial expansion, if you guys know of 1 plus x to the power n and 1 plus x to the power minus n, then this will be a very piece of cake for you. But if you guys don't know, then for your sake I am writing it. The formula of this 1 plus x to the power n is simply 1 plus nx plus n minus 1 by 2 factorial x square and so on. We just require 1, 2, and 3 terms. All right. Now this term can be replaced like replaced n by minus n. So you will having this like this, and when you put minus n here and minus n here, we will take minus common. This will become n plus 1 upon 2 factorial x square and so on. So this is the formula. Note it down because we have to use in each and every questions of Gauss test. Without this, Gauss test cannot be performed. All right, now what we have, let's write it again. Today my red pen is not working smoothly. I don't know why. All right, so we have this product. Now we will expand it binomially. Now you can see that this follows the expansion of 1 plus x to the power n. I can write it 1 plus 3 upon 2n in place of n, and then in place of x I have written 3 upon 2n, and n is simply 2. So this 2 cancel. Now again we have plus. N means 2 minus 1 upon 2 factorial. In place of x I am having what? 3 upon 2n. The 3 upon 2n whole square we need. Whole square. Okay? This should be placed in bracket and give a product sign. I'm having 1 minus nx. So here I'm simply putting minus 2 upon n. Okay, and then plus 2 plus 1 upon 2 factorial, and in place of x I'm having 1 by n square. Okay, now let's rewrite it more clearly. This term is getting cancelled, so I left with 3 upon 4n square, 9 upon 4n square, and this term is 1 minus 2 by n, and you can see that it is 2 into 3. So actually 2 will get cancelled, and I'm having 3 upon n square. Okay, yeah, so this is the final result, I will say. No, this is not the final result, because I can see that this is there is one mathematical operator over between them, and that is multiplication. So did you mean to say that we need to multiply these? So, yes, you have to multiply this. How? You have to multiply 1 by this term. So I'm writing it clearly, and then again with these terms. So 3 upon n into 1 is 3 upon n, and again this is going to be 3 2, 3, 2 is 6 and n square. And then I have 3 times 3 is 9 upon n cube. Okay. And then I have 9 times of 1, we have 9 upon 4 n square. And again this is going to be minus 18 upon 4 n cube. All right, okay. I can clearly see that I'm writing it here. This is 1. I left with 1. Here 3 upon n and minus 2 upon n is going to be what? 1 upon n. Okay. And one more thing, to make it look more simpler and not going and not doing so many steps, just look the formula of Gauss test once. The expressions of Gauss test. We require an alpha, and we require a term contains 1 by n and another term that contains 1 by n lambda. Now here lambda must be greater than 1, that is lambda must be positive, and here Rn is a bounded sequence. Now you have to show that Rn is also a bounded sequence, right? So for that I am taking lambda as square. I am not doing it further, so I am just taking 2 to 3 steps more. So here 1 by n I get it here, and then I am taking 1 by n square as a common over here. All right, so I am taking 1 square as a common. I left with, what do it I left with here, 1 by n square यहाँ है, 1 by n square यहाँ है, और 1 by n square यहाँ है. Can you guys see it clearly? So 3 minus 6, okay, plus 9 upon 4. Okay, and not like this. Okay, now I'm writing it there. So I'm writing it here, 1 upon what we have, 3 minus 6 plus 9 upon 4. Now what is the condition? That alpha plus beta upon n plus Rn to the power n lambda. So I have fixed that lambda is 2 here. This is in my hand. You can fix lambda as 2. Now you have to solve this. I'm taking 4 as a LCM, so I am getting 4 3 is a 12 minus 24 plus 9. Okay, now it is 1 plus 1 upon n plus 1 upon n square. And if you solve this, you can here see that minus 12 plus 9 is minus 3 upon 4, right? Now here you can see that you can write it like this, that 1 plus 1 upon n plus Rn upon n square. Now where Rn is minus 3 by 4 as n tends to infinity. Okay, n tends to infinity pe Rn is minus 3 by 4, and therefore we can say that, and therefore this Rn is bounded sequence. So that is the first condition for the Gauss test. Once it is bounded, see that alpha is what? So here alpha is 1. So means we have to go to look to the beta. Here beta is also 1. Means that this, hence the series is, that is un, is divergent. Okay, such a easy question. Here comes the another question. So first we have to write the un. Un is a 1 square, 3 square, 5 square. This is the square of all odd terms. So this must be 2n minus 1 square. 1 minus 1. Alright. In denominator part, we can see that this is a square of all the even terms. So it's going to be 2n square. Alright. Now un plus 1. Un plus 1 will be 2n minus 1 square. We will put n plus 1 in place of n. So we will get 2n plus 2 minus 1. 2n plus 1 square. And in the denominator part we will be getting 2n plus 2 square. All right. Now we have to do un by un plus 1. So you can see that these term from this to this will get cancelled. Okay, I'm only left with 2n plus 2 upon 2n plus 1 square. Now I'll take 2n as a common, 2n square as a common. So I'm getting 1 plus 2 upon 2n upon 1 plus 1 upon 2n. Okay. So finally 1 plus 1 upon n square and 1 plus 1 upon 2n to the power minus 2. Now you have to expand this binomially. Alright, I'm going to write it. 1 plus this is 2 by n, this is going to be, and then again this is plus n minus 1. So 2 minus 1, 2 minus 1 is 1, and n square by 2 factorial. So by 2 factorial into 1 by n square. So this will get cancelled. Now here 1 minus 2 by 2n, then plus 2 minus 1, that is 1, divided by 2 factorial into 1 by 2n square. Alright, and so on here also. So here also 2 will get cancelled, I guess. Yeah. So let me write it freshly first. 1 minus this will get cancelled, 1 by n plus 1 by 4n square. I made a mistake over here. I'll get like this is 2 and 2 plus 1, right? So 2 will get cancelled. I will left with 3, because sign will be taken as taken out, because this is a minus 2. So I'll put minus 2 minus 2 minus 1. So if I take minus as a common, this will become plus. So it will become 3. Now I have to multiply. Okay, this is a very easy step to multiply this. Just simply multiply. And this one, this is 2 by n, and this is minus 2 by n square, and this is plus 6 upon 4n cube. Now it is getting higher power. Again we have n square term left, 1 by n square, and then it is going to be my n cube. We are not interested in going too much higher power. We will stick to n square. Okay, because lambda can be fixed by taking any square or cube. We are good enough to put square in place of lambda. So 1 minus 1 by n. So 1 by n is common here. 1 by n, 1 by this is 2 by n. So it's going to be, this is minus sign is there, so write it like this. Okay, now again plus 1 by n square, right? And I have here 3 by 4, and here I have minus 2 and also plus 1. So you have to solve this. It will take 4 as LCM. So I will get 3 minus 4 to the 6 and plus 4. So this is 1 upon this is minus 1 upon, this has to be minus 1 upon 4. No, this is coming out as a 1 by 4. All right, so write it freshly. 1 plus 1 upon n plus 1 upon n square, and I'm getting 1 by 4 here, right? Now this is in the form of alpha plus beta by n plus r to the power rn by lambda, so n to the power lambda, right? So I can say that Rn tends to 1 by 4 when n tends to infinity and it is bounded. Also alpha is equal to 1, so we will look to beta. So beta is also 1, so it is divergent. All right, so it is divergent by Gauss test. So आपको ये टेस्ट बहुत इजी लगेगा. यू कैन अप्लाई. जैसे आप डी एलिम्बर्ट्स रेशियो टेस्ट करोगे ना, तो डी एलिम्बर्ट्स रेशियो टेस्ट के बाद अगर आप रैबिस टेस्ट करोगे, देन लॉगरिथमिक करो या फिर डी मॉर्गन्स करो, कितने करोगे, आप सिंपली गॉस टेस्ट लगा दोगे ना, तो बहुत इजीली रिजल्ट आ जाएंगे. और एक प्लस पॉइंट क्या है ना, this test never fails. So you can blindly trust this test. All right, so we will going to meet you in next video. Till then, stay tuned and keep learning. Bye bye.